This video discusses the procedure for the observations experiment for general chemistry at Madison College. For this experiment, for the first part, you're going to be doing reactions with metals. The two metals that you'll be using are copper and zinc, and you'll find small pieces of them in plastic containers in the front of the room. You want to get 2 pieces of each type of metal. Get tweezers from your lab drawer to get 2 pieces of each type of metal. Before you do any reactions, you need to do observations of the metal, and the procedure asks you to make both qualitative and quantitative observations. Qualitative observations are those that you can make with your eyes, so you're recording what it is that you see. Examples of your qualitative observations would be recording the color of the metal. You might want to record that it's a solid. You could talk about the fact that it's shiny. So those would be 3 examples of qualitative observations of the metal. The quantitative observation that you're going to be doing is finding the mass of each piece of metal. To do that, you'll need to go over to the balances in the lab room, and you want to weigh out each piece of metal. Because the pieces of metal are so tiny, it can be hard to put it on and off the top of the balance. I would suggest getting a plastic weigh boat and putting the pieces of metal in the weigh boat, and that'll be easier to take them on and off the balance. Remember to tare the balance with the weigh boat on it alone before you put the piece of metal in. You'll need to record 4 masses, 1 for each piece of metal that you obtain. The other reactant that you're going to be using in part 1 of this experiment are 2 solutions. Hydrochloric acid, which is the clear colorless solution, and copper 2 sulfate, which is the clear blue solution. You'll want to record 3 qualitative observations of each of these solutions. Notice the warning labels on the hydrochloric acid. That solution is corrosive, and if you get it on your skin, it would cause a burn. Be careful when you're using the hydrochloric acid, and if you spill any, be sure to tell your instructor. After you've gotten observations of all of your reactants, you're going to want to get the test tube rack from your drawer and label 4 test tubes for doing your reactions. The labels for your test tube are reacting each metal with each type of solution for a total of 4 reactions. You first want to put your solutions in the test tube. You want to get 1 dropper's worth of each solution. So that's going to be 1 full squeeze. There'll be 2 reactions with the hydrochloric acid, so you'll do 1 full squeeze of the hydrochloric acid in 2 test tubes, and 1 full squeeze of the copper 2 sulfate, that's your blue solution, in 2 other test tubes. Once you put the solution in each of your test tubes, then you'll want to use your tweezers to add the metal to the test tube. Your data table has a spot for you to record your initial observations, and those are going to be your observations of the reaction immediately after you combine the 2 reactants. So right after you add that piece of metal to the solution, you'll want to write down if there's any immediate effect and record your observations for the 4 different reactions that you do. You're also going to continue to observe these reactions over the course of 15 minutes, and you'll want to write down your final observations of the reactions after 15 minutes. When you're all done writing all of your reactions, recording all of your observations for these reactions, you want to clean out your test tubes, and you might find that there are pieces of unreacted metal in the test tube. The instructions for the lab ask you to filter out any metal that didn't react over a paper towel in the sink, and that's to prevent the metal from going down the drain and clogging the drain. Those pieces of metal that you collect, you can put them in the waste container at the front of the room, and this is to prevent them from going down the drain. So this is any metal that didn't react in your reactions for part 1 of the lab. You can wash your test tubes with a little bit of soap, lots of tap water, and then do a final rinse with deionized water and put them upside down in your test tube rack so they can dry out for the next people who do the experiment. In the second part of this lab, part 2, you're going to be doing a reaction between mystery solution and a mystery powder. You're going to be doing this reaction in Ziploc bags. Those are just the plastic resealable bags that you can buy at the store. And you want to get 3 of these Ziploc bags, and you're going to have the following labels on them. MS stands for mystery solution, and in that Ziploc bag, this is going to represent a control where you only put the mystery solution in. The second Ziploc bag, you want to label water plus MP. This is another control where you have just the mystery powder, and in place of the mystery solution, you're going to add water. This is another control. The third Ziploc bag is going to represent your reaction, and this is where you're mixing the mystery powder with the mystery solution. So MP plus MS stands for mystery solution plus mystery powder. What I can tell you about this reaction is when you mix your mystery powder with the mystery solution, they react to give you a gas. So I want you to think about what you might expect to see inside your clear Ziploc bag if the mystery powder reacts with the mystery solution and generates a gas. Now, if you seal that Ziploc bag, one observation that you might see is you might see that that bag starts to inflate. You might also see bubbles forming inside your Ziploc bag. So these are just some things to think about as you start to set up your reactions. So let's talk about how to obtain your mystery solution and your mystery powder. The mystery solution will be in these clear jugs, and you need to measure out 50 milliliters of the mystery solution, and you need to do this twice. You're going to put 50 milliliters in the bag that's labeled MS, that's your mystery solution alone, and you're also going to put 50 milliliters in the bag that's labeled MS plus MP. That's your reaction where you're reacting the mystery solution with the mystery powder. For your third Ziploc bag where you have just the mystery powder plus water, you need to measure out 50 mils of deionized water using that graduated cylinder, and you're going to put that in your third Ziploc bag, the one that's labeled water plus MP. Once your Ziploc bags have all of the solution or the water in them, then you're going to go to the balances and weigh out the mystery powder. And you can see that the mystery powder is in labeled containers by the balances, and there's scoops to go along with them. You need to weigh out about 4 grams. It doesn't need to be perfect, but about 4 grams of the mystery powder 2 times. Get a plastic weigh boat to weigh the mystery powder in. After you've weighed out your mystery powder, you want to find the green box of Kimwipes, and this is just a special type of lab tissue. It's a white tissue, and what you want to do is get one quick Kimwipe and lay it out on the lab bench and pour the mystery powder into the Kimwipe and roll it up. Once you've rolled it up, you can twist up the ends so that it looks like a wrapped piece of candy is how I like to explain it. But you can see that there's an example of it right here, what it'll look like after you've rolled the mystery powder into the Kimwipe, into that lab tissue. After you've rolled up your mystery powder, you want to put that into the Ziploc bags where you have mystery powder. So that's going to be the one that's labeled MP plus water and the bag that's labeled MP plus MS. In the third Ziploc bag, the one that's labeled MS, where you don't have mystery powder, put an empty rolled up tissue into it. So you won't put any powder in the Kimwipe, but you'll roll up the Kimwipe just like you did with the others to serve as your control. So you'll put an empty Kim wipe in the bag that's labeled MS. This is what your bags will look like. So you're going to have this soggy tissue inside of them, and you'll see that you'll have the liquid at the bottom of the Ziploc bag, and you'll mix your reagents together that way. So in addition to your observations of the 3 Ziploc bags that you have, we're going to do an additional test, and the additional test that you're going to be doing is called a splint test. A splint test involves a wooden splint, and you can see there's a wooden splint in this picture here. It kind of looks like a wooden coffee stirrer. You want to get a box of matches, and you're going to light the end of the wooden splint. And the purpose of the splint test is to test the mystery gas that forms in our reaction. So you're going to take the lighted splint, and this helps if you work together with your partner. So one partner can hold the lighted splint, and the other partner can open up the bag. You want to take that lighted splint and put it into the headspace of the Ziploc bag, where any gas that forms is going to be located. It's going to be trapped in the bag. The purpose of the splint test, so remember that when we mix our mystery powder with our mystery solution, we get a gas. We don't know what the gas is, but we want to do an additional test of the gas. What we can conclude from the splint test is that there's 2 possible results. So you might take that lighted splint with the flame on the end, and you stick it into the gas in that Ziploc bag, and the splint stays lit. What that means is that if you still have a flame on your splint and it stays lit, you know that the mystery gas is flammable. Or another way we could explain it is that it supports combustion or supports the flame on your splint. If you take the lighted splint and you put it in the Ziploc bag and that flame goes out, the splint goes out, your conclusion is going to be that the mystery gas is not flammable, because the splint went out and it doesn't support the flame. So the splint test doesn't tell us what the mystery gas is, but it gives us additional information about it. So it's just one more test that we're going to do to test the properties of the gas that forms. This is the last test that you'll be doing and the last piece of data that you'll record for this experiment. When you're all done with your Ziploc bags, pour out the solutions and you can throw away the Ziploc bag and the Kim wipe and your used splints in the trash. I hope this video helps you prepare for your experiment this week in lab.